Hello and welcome to a quick tutorial on streak line, streamline, and particle paths using TechPlot 360. I'm using TechPlot 360 2014 R2. Let's first go ahead and load a solution. The solution we're going to load is a unsteady solution of vortex shedding. We'll look at first few time steps, and since this is in a solution that has a mesh that doesn't change, we'll just pull down, grab the mesh as well, add it to the list, and maybe we'll just take the last couple of time steps. Doesn't really matter. We'll add these to the list, and we'll go ahead and open them. Now, I want to point out quickly that you can see the progress bar. It's reading through the additional solution times. You'll notice that it says here that it's setting up zones. It's not loading any data. We're merely going through, we're looking at all the time steps. What we're trying to figure out is, okay, is the mesh moving, which in this case we only have one mesh, but if it were, it would start to assign zones. It's looking for time step information that it will use to assign a time strand, which is important for when we actually do the streak line calculation. But in this case it is not not loading the data, which is good because we're talking about, I think all told, this solution is close to about 7 or 8 gigabytes, and it just would take a long time to load. Okay, so once it's done, you'll see it will open up. Basically what you're seeing is the extent of the domain in the volume for each of the blocks in the solution. I'll go to Zone Styles dialog, and I'll just select one. I hit Control A, which basically selects all the zones. The surfaces that we're going to plot are the J surfaces, I believe. So if you right click here, go to the J planes, you'll see that it will identify the cylinder. These particular J planes aren't necessary for the solution, and we're going to go ahead and see if we can't select these guys, and we'll go ahead and hide them. And really you have a number of things you can do. Hide basically says, okay, I don't want to see that in my domain. So for example, let's select these guys, and same thing, I'll hide them. Or you can do them individual, it really doesn't matter. It's pretty straightforward. And all hide basically is telling TechPlot is, hey, I don't really need you to plot anything, so please turn off the surfaces. So we're back to just our cylinder. In general, you can show the extent of the domain. I'm going to turn that off. It's not as important. And you can see it's just a simple cylinder. Let's drop in a slice. The slice is going the X direction. If I want to change it to the Y direction, I can just type Y. And that's actually perfect, because what we want to do is look at streamlines and streak lines on either side of the cylinder. To turn on stream traces, we'll select stream traces, go to the stream trace tool. At this point I'm just going to create a rake. I'm not going to put in individual positions. I'm going to get 2 rakes, a rake on the upwind side and a rake on the downwind side. And I'll show you why that's important here in a second. You can see these are 3D, and if I animate, you'll see that these are instantaneous stream traces. Effectively, every time we go from time step to time step, it's going to recalculate or reintegrate through the vector field based on the seed position for each of the lines. Okay. So this is, for a steady state solution in particular, stream traces are basically fine. But we're quite interested in looking at streak line analysis and particles with mass. So let's go ahead and press pause. There's a lot of solution time steps I've brought in. We don't need to see them all. So we're going to move first into the analyze capabilities, and we're going to go to particle paths and streak lines. So there are 2 types of calculations one can do, a particle path or a streak line. Particle paths will follow effectively the streamline, or the original streamline from T0. The thing that would make them interesting is that you can use mass, so we can use a ballistic coefficient, we can use ablation, and the idea here is that in principle you can start those particles with 0 velocity or specify velocity, You can start them with gravity in the minus x, y, or z, plus x, y, or z position. So that's one type of calculation. It also has an integration time step. This is related to when you're doing streak line calculations, which we'll do. Now, a couple things on streak lines. You can release more than one particle each time step. So a streak line calculation is different than the streamline integration in that effectively it's going to release those particles in time, and when it goes to the next time step, it will release particles based on where those particles have migrated in the vector field from the first time step, and I'll show you what that looks like here in a second. We'll release, say, 2 particles per time step. We're going to do this per solution time. We'll leave the default on the integration time step, and we'll hit calculate. Okay, so it looks like that finished. Now, depending on the size of your solution, the number of time steps, the calculation for particle paths and streak lines can take a while. I mean, it is actually takes a fair amount of computational resources. Once it's done, you'll get something that will say that the velocity have been stored in the current vector variables, and it will say it was successful. We're going to turn on the scatter symbol. And scatter symbols that are being shown right now, if we go to zone style, you'll see that we have a series of streamlines. And we'll go to scatter, and we'll just confirm that in fact for the majority of the zones here, we don't want to show scatter. Okay. Oops. Streak lines we do, by the way. So there we go. So we'll start here, go down to the bottom, there are 20 of them, and we'll select them. Outline color, I'm going to change that to just be row. And in terms of scatter size, I'll make it a little smaller. I'll close this. Now we're at the end time step here. We're going to actually go back to the beginning, and if I animate these stream traces, or animate these streak lines, you can see now there are the particle paths, or the streak lines in this case. So they're evolving in time, and they're going to go through, and as we go through the solution, they'll actually develop. So this is a simple way to look at those streamlines. Now the dialog doesn't dismiss, so I'm going to interrupt here. I'll just move it off the screen for the animation effect, and you'll notice that if I hit play, that the streak lines themselves aren't really animating. That's because they're stored slightly differently. So, not a big deal. I just wanted you to be aware that you have to animate these streak lines from the dialog. We'll press pause here. So let's animate this as well. So you can see those streak lines developing, and so it's a relatively easy operation to generate streak lines. In this case, you'll see that we're actually obscured a little bit because of the slice. I'm going to turn the slice off, so I will stop this for a moment. If you want to turn off the slice, you can actually just double click on the slice here. Oop, that's a stream trace. And you can turn it off, or just undo slices. Undo the stream traces. Let's rotate this around a tad. We'll see the scatter here is actually shown for the zones here. We're going to perhaps turn on translucency so you can see it a little better. And now we'll go ahead and animate again on screen, and so you can see where those streak lines are going as they develop in time. So it's a pretty nice way to look at turbulent flows. And you'll see that it continues to release 2 streams per time step. It looks like the streamlines or streak lines on the upwind side seem to be kind of slowly approaching the cylinder. And that's how you do the calculation. Again, you can also use mass. So if you want to use mass, you can use ballistic coefficients as well. So there's lots of different options. You can change the integration time step. You don't have to release it just with the solution time level. You can make it arbitrary. And that's how you do streak line animation. So In the next tutorial, we'll be talking about gradients and shadow graph calculations. Thanks for watching, and see you in the next tutorial.